Okay, so we are recording class 3.2. So before spring break, I had missed several classes, posted recordings to finish up module 2, 2.2, and 2.3. The module 2 exit exam looked like it went pretty well. I think the average was like 90 or so on that. And I'll have to go back and look. And then the last class before spring break was supposed to be 3.1, so I posted that lecture too. So we will jump into class 3.2 on the processes and technologies of the third industrial revolution. So the third industrial revolution, for our intents and purposes, kind of defining as roughly post-World War II-ish. And so the late 40s, early 1950s and beyond is kind of the time era that we're going to talk about. And so to understand what the world was looking like at that time, Germany after World War II, based on the Marshall Plan, the US and the Soviet Union kind of divvied up parts of Europe in terms of helping them reestablish themselves. Part of this surrender, Germany was actually deindustrialized. So to hold them back, a lot of Europe was recovering due to the war being fought on their land, and there were intentional efforts to reindustrialize Japan for strategic purposes, and the U.S. economy for the emerged as the world's largest at the time. And so that's kind of what was going on. So a shift in engineering and technology focus in this country started to take place specifically toward defense with the nuclear arms race post World War II. So the World War II was kind of brought to an end with the introduction of the atomic bomb, the reintroduction of the atomic bomb a couple of days later. And so then that kind of brought the engineering emphasis on the arms race, aerospace systems, and then also this race to the moon that was starting. And so I believe President Kennedy in the early 60s said we're going to put a man on the moon by the end of the decade. And they slipped in right in the last year of the 60s and did that. So a lot of engineering efforts. So in Huntsville, Alabama, for those of you that are local, this kind of dominates a lot of the landscape of this town to this day. The Saturn V rocket in this picture that launched man to the moon for the first time kind of towers over the city. Lots of space, lots of defense engineering in this town, and nationally, that's where a lot of engineering efforts started to shift post World War II, and also globally, because at the same time, in parallel, the Soviet Union was focusing on these exact same things, which kind of defined what they called the Cold War during that era. So, Germany was split. I even had a globe when I was growing up that had two Germanys, an East and a West. And the US and Soviet Union kind of took over shepherding the different sides. West Germany for the US, East Germany for the Soviet Union. And initially they did deindustrialize Germany, but then realized while the rest of Europe was kind of fallen behind on technology because they were fighting the war on their front, but then ultimately realized that it wasn't doing anyone any good for Germany to be deindustrialized and started to rebuild them back about a decade or so after the war. In Japan, totally different story. General MacArthur was the supreme commander of the Asian front there to help Japan rebuild, and they wanted to help Japan rebuild their industry immediately. Yeah, strategic location there. near China. So a lot of the things that we discussed at in module two, specifically in I think class 2.2, we're on with the processes and technologies of the second industrial revolution. We said the focus of the engineer shifted, or not shifted, but added on responsibility. In the first industrial revolution, the focus of the engineer was inventing in technology, and we tried to be productive with that technology. And so in the second industrial revolution, that's where we saw Frederick Taylor, the Gilbreths, and we said we could increase productivity through time, through motion, and through productivity. We talked about Henry Ford and the assembly line, but then also talked about training with an industry program, which was an emergency war program that helped U.S. manufacturing be competitive and have an advantage during World War II when the demand for things goes up during war, and the people who typically worked in factories were being drafted. Both of my grandfathers were drafted to World War II. And so they were leaving factories, going to fight the war. And so we had this weird time where we needed more than we've ever made before in doing it with people who never worked in factories. And so they called that emergency. And they developed these programs: job methods improvement, job instruction training, job relations management, through a consulting group called Training with an Industry. And after World War II, Training with an Industry, kind of everybody came back and the war was over, and companies stopped using it here, but it was used to help Japan rebuild during that time. Now I go, and I think I've mentioned several times, I've done work with Toyota. I'm doing a lot now with Mazda Toyota, and they have documents called job instruction training and job instruction sheets that they use, a lot of the remnants of the TWI programs to this day. So not only did the TWI folks go as part of the contingent that was helping Japan rebuild industry, but there was also a couple of prominent quality gurus, Joseph Duran and Edwards Kimming, that played a big role in working with Japanese industry as well, and were very endeared and embraced in Japan. So we looked at, in the first industrial revolution, the role of the engineer, invent technology. Second industrial revolution, not only we're going to continue inventing, designing, but we want to be more productive with things. And then in the third industrial revolution, another role of engineering that's added is not only, it's not okay just to be productive if we're sacrificing quality. So the role of quality in engineering came into focus. So got a few of you here in person, a couple of more on Zoom. When I say quality, tell me a specific company or product or something. When you hear quality, good quality, what do you think of? Toyota. So there was no right answer. No, I'm curious. I think of Toyota.
Seems.
I mean, I do. I drive one. They don't tend to break. They last forever. That can be a good or a bad thing. I had one that lasted 16 years out of Tacoma. Like, it was old enough to have its own driver's license, right? Like it was. Then I got a new one, and I was like, oh, there's like 3 generations of technology I didn't even know existed. That, like, maybe I shouldn't drive something 16 years. I didn't know I needed all of this cool stuff. What else?
I think of like the TV show, like How It's Made,
Okay.
or whatever.
Mhm.
Especially like on the lines, and they're like pulling stuff off the lines and they checking it and they get it back. But also when I worked at Frito-Lay, we would do quality checks twice per shift, and we would talk about 3 different things: the appearance, the taste, and the and texture. and stuff like that, and you would do that and how it's important to, in doing that as well in these walls, we would do like, wand checks with all the bag makers to make sure like metal detectors are operating correctly and stuff like that, so if anything went off, that we would be able to catch it, and line walks as well, so I think that would go with your quality. But
And so quality can be features, can be like durability. I mentioned with Toyota, right? Like a last long time. It could be a function, quality check, department, right? Nuts.
First thing I thought of was like Calvin Klein dresses versus like your cheap Marshall strips. You can't find them both in the same place, but a Calvin Klein dress is gonna last you a whole lot longer and it won't fall apart on
Okay.
maybe like name brand.
you. Yeah, well, no, it's not name brand. Like sometimes name brand stuff is cheap, but like it's like if it's a quality, piece of clothing or whatever, it's not gonna fall apart on.
Please trust Calvin Klein over something.
Over
Trust.
something.
It's a good one.
Yeah, that's why like I think like a lot of people like buy these like Yetis or Stanley cups
Okay,
because
Yeti, it's for real.
I've dropped mine and it doesn't spill, so
Yeah.
um so I like to play that little game because we all have our own ideas of what quality means, right? It's a hard thing to get your head around and define. And so like that's why when all of a sudden we said, hey, we need to focus on quality, it's like, great, what is it? Like it's ill-defined sometimes. So
well, it's like buy something. Last long, be real. I mean, I just bought monthly bars and one of them is open from the seal, and so they failed. Yeah, they failed that one.
yeah.
That test, but I trusted the company to make them, and they let me down that one time.
No, you're not gonna.
No, I'm gonna still get the monthly bars.
We'll come back to that comment you just made in a minute, though, a little later. So there's generally 4 determinants of quality that we can at least start off with that says, what do we mean when we say something is quality? One of them is quality of the actual design. The design of the product or service that the customer wants is where quality starts. In other words, the best workmanship in the world. I could make something great, but I can make it to a poor design and it's probably not going to be good quality. Hey, you built this right to spec, but it was just a bad spec. I worked for a company early in my career in West Alabama. They made flatbed trailers. So like the 48, 50 foot, 3 foot long things that are hauling stuff down the interstate and throwing rocks under your windshield and stuff, like they made those. And they were rolling out at the time I was working with them, a new model of trailer that had aluminum side rails on it and it was really sleek. And they had designs called the Renegade, and they had designed a tail skirt, the part that kind of hangs down. If this is the flatbed, it's what you look at when you're driving behind them, trying to see if you can get around them. And they had a plasma cutter that cut the name Renegade in it and it had a mirror surface on it. Really shiny, really cool. And after about 6 weeks of circulation, the Department of Transportation flagged them and had to have them recalled. Why do you think that was?
Blinding drivers.
It's blinding people. Yeah, you get behind one of those on an August sunny Alabama day and like really seemed like a great idea, bad design, even if it's built great. On the flip side of that, determinant number 2 is, given that it's a good design, we have to build it to conform to that design, quality of conformance. So quality of design says if the best workmanship in the world can't overcome a bad design, well, the best design in the world also can't overcome poor workmanship if you don't build it well, which is what I think Toyota does really well. I've been in their factories, I've been in other automotive assembly plants. I see what they do and they just build things differently and build them well. And then determinant 3 is, got a good design, we built it to that design. How easy is it to use? Because if it's difficult and I only use 10% of the features because I don't know how to utilize everything, then am I fully getting out of it what the design intended? And that could be interface, a lot of cool stuff some of my colleagues are doing in terms of user experience, user interface, things on designs, human factors from a ease of use standpoint. It's really cool. And so Apple's really good at that, in my opinion, making things seamless, intuitive, simple to use. I remember I started using a MacBook 2010. Never used one, never touched one, had no clue about it. I just knew it couldn't be worse than what I was used to with the PC Dells that I was always given here at UAH, and you power them up and they immediately, like new ones, get slower the minute they turn on. And after a couple of years, they were just impossible, and you get the blue screen of death. And I just remember saying, I don't know what it is about a MacBook. I don't know how it works. It looks different, but I'm going to jump in. And within a couple of weeks, like everything made sense. And I never looked back, and I've never had to hit Control-Alt-Delete again. I'm 16 years. It was just easy to use, and it seamlessly crosses over. I think that's a strength of theirs. And other people have closed the gap on that some. And then the fourth one is, when things do go wrong, how easy is it to get service? Because that can be a determinant of quality as well. When things do go wrong, sometimes, like, I will build loyalty to a company just because they have great service. I think of Chick-fil-A as having really great service, whether the upfront and on the back end if you do need something corrected. So that brings a sense of quality. So just defining what quality means can be a challenge. And so I wanted to cover that. Then I want to talk about a couple of folks in the quality world. Joseph Juran and Edward Deming, very similar backgrounds. Crazy enough, we talked about the Hawthorne effect and the Hawthorne studies in class 2.3, I guess, where we were talking about motivation. And they kind of went in to study illumination to improve productivity. And then they found, oh, people have feelings. People pay attention to stuff. There's something going on beyond working because the lights are higher and lower because productivity went up anytime we paid attention to them. Well, at that same time that those were being done, both Edwards Deming and Joseph Juran were also working as engineers at that same facility. Now, that facility was huge. I can remember reading the essay about it. Weren't part of the Hawthorne studies, also did not know each other. But I just find that interesting because they both become prominent figures in their own right. So I wanted to talk about each one of them and their contributions to the field of quality. So Joseph Juran, his view on quality was, he defined it as fitness of use, or how well does the product or the service that we're offering meet the needs of the people that will use it. And three key things that he is known for, one of them is he said that quality should be viewed not as a department, not as a function, but as an overall management theory for the organization. So in module 2, we looked at 2 schools of management, the administrative management. So that was Henri Fayol and Max Weber. And they introduced administrative management. Then we had Frederick Taylor, Lillian Gilbreth, and Frank Gilbreth that kind of come along with scientific management view. And now we've got Joseph Juran saying another school of thought is quality management. It shouldn't just be part of it. It should be the way we manage our organization through a quality lens. And he was inspired analytically when it comes to quality by something called the Pareto principle. And the Pareto principle was named after Italian economist Vilfredo Pareto. And it's basically the 80-20 rule. Now, Vilfredo Pareto did a study in economics that basically said 80% of the wealth is controlled by 20% of the people. And the other 20% of the wealth can be spread out amongst the other 80% of the people. And so Duran took inspiration from this and said that actually that 80-20 rule applies to a lot of things in life. In other words, a lot of companies in the 90s went through this whole 80-20 thing, 20 thing. It was like a management fad where they said, oh, 80% of our business comes from 20% of our customers. Let's focus on them. And the other 20% of our business comes from the other 80% of our customers. But from a quality standpoint, a lot of times it's 80% of your problems usually come from 20% of the reasons that you could have problems. This is it. And if I can start to categorize them, then it can help me prioritize. Call it distinguishing between the significant few and the trivial many. So this is an actual Pareto chart from a company that I work with where we were collecting downtime. They coded stranded copper wire. So like if I were to strip this cord down, it would be a lot of strands of copper wire. And then this company would get raw material, stranded copper wire, and they would run it through a long extrusion process and coat it into different colors. Some of them would be multicolored stripes. They would have different sizes. And they had two lines. Get that back.
What company is this again?
Hmm?
What company again?
It was called Syndia. It's in Athens. It doesn't exist. This was a neat company. It was a small company, 4 guys that worked for International Wire. It was a bigger wire company, and they were sitting out on one of the guys' back decks drinking beer one night and said, I think we could do this. We could leave this company and start ourselves. So they bought 2 machines, ran for a while and sold it off. And so they were looking at buying a 3rd machine, but they were only getting about 60% of the output that they were expecting from the other 2. So before they did, they wanted to know if there were ways they can improve the efficiency of how it ran. So we started collecting downtime, and they were losing about 40% of their production time just from either the machine being down or not being able to run at full speed because of different parameters. Like, oh, my car can run, but if I get it up to 55, it starts shaking and things fall off. So I can't run it at full speed. And so we were actually, in part of the data collection process, we worked with the operators on the machine, and they came up with about 54 different reasons that they could have downtime. And so we just collected it over time and said, hey, if you're down, collect how long you're down and what the reason was. And then start to order them by most to least. And so the biggest contributor to downtime was something called a fuzz up, which I think is funny. It's one of my favorite words I encountered over the years. I think I've been called that a few times, actually. So, a fuzz up. My brother called me that a lot. But that accounted for the largest amount of downtime, which was about 40% of the total downtime. And if you add the second most common, wire break, then those 2 together accounted for a little over 60%. And if you add the third one, which was a vendor weld break, those 3 together was close to 80%. So it's saying, 53% reasons that you could have downtime, but 80% of your downtime comes from those 3. So guess what? Let's focus on those 3 instead of the trivial many over here. So it's a way to prioritize. That's what the Pareto principle was inspired Duran in terms of prioritization when it comes to quality. And then he also is known for what they call the quality trilogy, which allowed him to work with companies to better capture cost of quality. Because his argument was at the time that the majority of companies only measure the cost of quality when something goes bad. A reactive measure of cost of quality. But he also said quality really can take 3 phases beyond catching it at the end. There could be quality in planning up front. So like we said, best workmanship in the world can't overcome a poor design. We can take care of a lot of quality problems by having a good design up front. Then during the process, we can have quality control, which is limiting variation, measuring the product every so often, seeing how we're doing. And then we can have quality improvement, which means how do we get better? But his argument was that if we invest in quality up front, the total cost will be less than if we only focus on it at the end. So in other words, if we invest in, there's cost of prevention, which is what if I invest in planning up front, designs, air proofing, don't need to go back.
I got it. Thank you.
And then during the process, what if I invest in cost of appraisal, which is inspection, testing, sensors, detection, instead of only focusing on the cost of failure. And then when there's failure, there's actually 2 types. There's internal failure, which is what it cost us that incurred up until that point where we found out that it failed. So in other words, I have this phone gets out to the customer, then I have the cost myself of the material, the labor, everything that went into making it. But then there's the external cost once it gets to the customer, which is the cost that is incurred to address it. So there's the direct cost, which can be returns, warranties, recalls. I saw Ford, I think, had a big recall a week or 2 ago. But then there's also the indirect cost of letting poor quality get to the customer. So what was it? The bar that you said let you down? What was it?
Oh, it's a Nature Valley muffin bar. It's chocolate chip.
Nature Valley chocolate chip muffin bar. And
It was open when I was gonna have it for breakfast this week.
so you bought a box of them?
Yeah,
One of them was
yeah,
open?
one of them was open. I've had like the Pillsbury. One of them had like no air in it, so it made
Just kinda-
dough like super dry and stuff. Like you can report it. That's what you're supposed to do. That's what we had at Frito. We'd have like fun day of quality per week, and they would tell us about all the fun things that they would get from the customers. And they would get awarded some type of coupon or something like that.
So there's the direct cost of fixing it, then there's the indirect cost of, at some point, if people have a bad experience with our product or service, it's going to start hurting our reputation, right? I think marketing studies say people will tell 9 times more people about a bad experience than a good one.
Yeah.
So think about it. Have you ever had a bad experience at a restaurant?
Yeah.
Did you tell anybody?
Yeah, I told my parents.
Anybody, right? Like, hey, anybody that'll listen. But then if you don't, hey, I went, had lunch today, didn't get sick.
Yeah.
Don't really tell that many. If it's exceptionally great, maybe, but still probably not as many as we tell about it.
Yeah.
SIE scores tend to back that up as well. 9 times as many people will fill out the SIEs for bad things than good ones. So there's the indirect cost of quality as well. So Juran was the first one to kind of start to say, hey, if we, instead of only measuring the cost of quality at the end, if we can invest, then we should have less cost at the end, and the collection of all three of those will be less. And so he worked with companies in his consulting days, better quantify the cost of quality in that way. And then one of my favorites, Edwards Deming, his view on quality was consistency, uniformity, dependability. He was a statistician and was a pioneer of something called statistical process control, which is fundamental to a lot of industrial engineering education. And statistical process control basically uses the normal distribution to set boundaries of plus or minus 3 standard deviations so that you can understand common random variation versus specific cause variation. And so specific cause variation is where you can actually do problem solving. And so statistical process control, and I won't get into an SPC class tonight, but he was a data-driven statistician that used that to drive quality. Another thing that he was known for was the Deming cycle, is what the Japanese called it, or the plan, do, check, act cycle, and his 14 points of managing quality, which were more at the higher executive level. So the plan, do, check, act cycle, this is something I preach to this day. I actually, the class session I had right before this was my undergraduates. I teach a section of our senior design class in industrial and systems engineering. And they were given a midterm update on their projects. They work in teams implementing projects at real companies. And so I have them report out using the plan, do, check, act cycle of problem solving. And Edwards Deming kind of made that popular, the scientific method of problem solving. Plan means understand the current situation. In other words, I'm trying to increase performance. There's something that's in front of me keeping me from getting better. There's some sort of problem. So plan is I need to understand the current situation. Go see it with my own eyes, collect data. That's what I have my students doing first part of their projects. Don't go in and start changing things before you understand the current situation. Because a lot of times what Deming was saying and what happens is when something goes wrong, people want to jump straight to doing something to fix it without understanding the root cause of why it happened. And a lot of times when we jump straight to do, we just treat symptoms. In other words, if I go home and I see a spot of oil in the garage under where I usually park my truck, which I'm hopefully not going to see because I do drive it weird. But if I saw the oil on the garage floor and I just said, oh, I'm going to jump and do, that's a symptom. I'm going to treat the symptom. I'm going to wipe it up and put cardboard there. That'll keep oil from getting on the floor. It will, right? But I treated the symptom, but it doesn't fix the root cause that there was oil leaking from somewhere. So plan, understand the current situation, understand the real problems that are in front of you and what the root causes are, so that when I go and do, I hopefully fix things permanently. But then when I do, I also want to check and say, did I actually get better? And then based on what I check, I act or adjust, which means if I got better, the adjust is I want to standardize so that I don't regress. Because if I don't standardize, even if I get better, I will regress back. Or if I plan, understand the problems in front of me, go and do something, check, performance didn't get better. Well, then we adjust by going back to plan and trying something. So that's one of the things I try to emphasize with students. Like today, we're not going to get things perfect. That's actually the atmosphere of experimentation as part of problem solving. And one of the teams that were actually designing some swag for us in the department. We want to start manufacturing some of our own stuff to give out at conferences and things. And I got them coming up with manufacturing processes, how to build all these things. And so they were building some prototypes and they were showing some things, and they had planned and then they done, and they were in the check phase of saying, oh, this is kind of locking up, and talking about what they learned and how they're going to adjust and do a plan for the next cycle. And it did. So Edwards Deming was one of the ones that emphasized this approach to scientific method of problem solving. He later called it Plan, Do, Study Act instead of Check. Toyota calls it Plan, Do, Check Act, or the Deming cycle. So that's kind of just the way I learned it. So that's what I stuck with.
Anybody ever refer to the OODA loop, the observe, orient, decide act?
Funny enough, I was actually at a conference in Tempe this past during spring break. It was an IEEE COGSIMA, cognitive situational management, and there was a lot of presentations on the OODA loop. There's a lot of overlap and similarities in that too, but actually I've one of my graduate students looking at situational awareness and the OODA loop and team performance and behavior. So it's very, very similar. And then the other thing Deming was kind of his major contribution. Another one was he called them 14 points. His 14 points of management, which were large, big picture observations that he was really, so Deming and Juran were quality people in the 1950s, like people that worked in quality. Like, I'm not commenting on their character. That's a quality guy. They were working in quality, and after World War II, no one really wanted to listen to them here. We don't need you. What's all this quality stuff? We're on top of the world. So they went to Japan. But then later in the 80s, they became really popular consultants here when everybody all of a sudden were wanting to improve quality because the Japanese manufacturing style had kind of gotten a lot of attention. So Deming did a lot of seminars in the 80s and the 90s. And you can actually find some on YouTube. They're quite entertaining. He was this older guy at the time. By the time this happened, he had this growly voice, and he would be in these large seminar rooms with 200 executives in suits and ties, and he's just dogging. He's just talking about. He would do these experiments with, like, he had this bin of red beads, white and red beads, and with a paddle, and you had to scoop out. And he would say, I only want you to make white beads, not red ones. Red ones are bad. And he would have these executives scoop out, and he would say, don't get the red ones. And when they would, he would just dog them. And I told you not to. You need to do this. And his point was, you're setting people up to fail. Best way is to not have the red ones in there to begin with. How do you deal with quality up front? And he was always talking about management likes to blame people when mistakes happen, but yet 94% of problems come from bad systems, not individuals. And people were not looking at systems and creating better systems. So he was a big advocate of that, and talking about how organizations need to think differently and have these focuses. And I won't read them all to you. I want to talk about how there's a lot of overlap. If we go back to some of the observations Henri Fayol made and his principles of management, there's a lot of overlap in that. But this Deming later in his career was talking more to strategic level. Organizations have a consistency of purpose. You should focus on building quality in, not depending on inspection at the end to catch quality. How do you have a process that builds quality in at the beginning, or catching it at your own process, not waiting until it gets to the end? kind of some of the things that Frederick Taylor talked about with training on the job and how it's the role of management to make sure that people are trained and set up for success. Denny was really big on discussing a lot of that stuff. And so, like I said, both of them kind of got ignored in the 50s, went to Japan, helped them rebuild the industry. Then as quality came to the forefront in the 80s, as we'll talk about in a minute when we get to Toyota, they came back and were more welcomed in the US as consultants to say, hey, help us with some of this quality stuff. We'll pay you a lot of money. So they worked with some major companies, wrote books and become more famous later in their life. And then a collection of a lot of their works and other people's during that time became known as a big management fad in the 1990s called total quality management, which was basically a set of tools and philosophies that kind of went back and took Joseph Turan's recommendation of treating quality as an overall management system. The problem with it, and it's a problem with that I see with any fad, is when companies were implementing it, they were doing it dependent on outside consultants who would come in to save the day, and they viewed it as a quick fix with short-term focus and not integrating it into their overall strategy. And when they would not get the quick results they expected, they would deviate from it and never, when you depend on outside consultants, and I did this for the first half of my professional career, I was basically working as an outside consultant, helping people do lean manufacturing with the Toyota system. And we always told people our goal is for you not to need to keep bringing us back, because for this to work, it has to be institutionalized. You have to own it yourself. And when you're dependent on outside consultants, it tends not to stick. So a lot of good things with the total quality management, TQM world, that didn't stick solely because of the poor execution of it. But now I want to spend a good bit of time talking about something near and dear to my heart, because it is what I would say I'm not very good at anything. I know like one or two things, and so lean is one of them. It's what I spent the vast majority of my career doing, is working, studying the Toyota system, not just the way they build things, but the way they manage and run their organization. And so the first documentation of the Toyota way of running a business was in a book called The Toyota Production System by a guy named Taiichi Ohno, who was an executive at the time, manager, largely considered the pioneer of developing the Toyota production system in the 1950s. And he published it much to the dismay of a lot of the people at Toyota. In the late 70s, it says, hey, by that time, Toyota had started to see success. What had happened was there was post-World War II. Then I think I may have even posted a video. We called it the economic miracle. Japan's economy rebounded post-World War II faster than any countries ever had after a major war at the time. And Toyota came into prominence in the early 70s in the US because of an oil embargo. There was which caused a fuel shortage. Gas prices went up. And in 1973, like in the US, if you find a vehicle that was made in the early 1970s, it's probably like a muscle car. I call them muscle cars or land yachts. Or my dad had a 1970 Chevelle Super Sport. Awesome car, but you could actually see the gas hand move when you drove it. It got like 6 miles a gallon. You could also take it down to the local drag strip right off of the car lot and compete back in the day. And so Toyota was making a different type of product, and they got noticed in 1973 during the oil embargo because they made money and no one else did. And so people were like, "What are you doing? It's so different." And that's where the calls for the book came, and Taiichi Ohno said, "Well, we call it work, but if we need to name it something, Toyota Production System, here you go." And it was translated into English into the late 80s. And during that same time, the US government funded a research study with the Massachusetts Institute of Technology, MIT, to study the automotive industry. And the results of that study were published in 1990 in a book called The Machine That Changed the World. And it was in that book that the researchers, the machine that changed the world, the lead authors were a guy named Jim Womack. He was the leader of that group, and they, in that book, coined what Toyota was doing. They coined the phrase lean production to describe the Toyota system. So if you've ever heard of lean manufacturing or lean systems or lean enterprise, that's where the actual name came from, was the machine that changed the world, using that term to describe the Toyota system. And then the same authors wrote a book a few years later called Lean Thinking that got popular in the business world. And people thought, "Oh, if I read this book, I can beat Toyota." So now Lean has deviated greatly. Everybody had put their own spin on it and deviated. I always go back to the true Toyota system because they're the ones that have had the results to back it up. But that's kind of the background of why people first started getting interested in Toyota in the West. But way before that, Toyota actually started not as an automotive company, but as a company that manufactured looms. So full circle, all the way back to the first industrial revolution, we were talking about looms and spinning machines, and looms weave fabric, and now all of a sudden we're right back to it. And Toyota Automatic Loom Works was the first company, and that is not a typo. Toyota with a D is actually the family name. They changed it to Toyota with a T because I always get the numbers wrong. The kanji character for Toyota versus Toyota has one extra stroke in it to make it 8 instead of 7, or vice versa, and 8 is good luck in Japanese. So that's the story behind that. But there's two primary principles to the Toyota system, and one of them came from the Automatic Loom Company. So Sakaichi Toyota was the founder of Toyota Loom Works. He was humble beginnings, son of a carpenter, rice farmer, watched his mother sewing and working her fingers to the bone, so he was an inventor. And one of his inventions was developing a loom that would stop on its own when a problem happened. So prior to that, if this machine was weaving fabric, if a thread broke, the machine would keep running. It would damage the fabric. It could actually possibly damage the machine. And so one person, even though it was automatic, would have to babysit the machine in case it broke so they could stop. But he developed a mechanism that if a thread broke, the machine would stop on its own and prevent the further damage. The Japanese term for that is chitoka, which is basically building in quality, stopping the process so the process doesn't cause problems. Today, if you walk out on many automotive assembly lines, but definitely Toyota, definitely at Mazda Toyota here in Huntsville, if there's a problem that is encountered on the line, every person is empowered to pull the cord or push a button. And if the problem persists, then they can stop the line. That's building quality in instead of sending it on and letting it be someone else's problem. So fundamental principle of the Toyota system was Jidoka. And the other is just in time, which came from the automotive branch. So in 1937, Sakaichi Toyota's son Keiichiro Toyota established Toyota Motor Company and almost went out of business, as most of the Japanese economy did during World War II. They rebuilt during the 50s. And part of their effort in rebuilding, learning from Deming, learning from the training with the industry folks, but they also sent a group of engineers and managers to the US to study Henry Ford's plant. So we talked about Henry Ford in module 2, right? The assembly line. And when they came back from that visit, they had ideas that would become fundamental to the Toyota production system and this thing called just in time, which is an inventory management philosophy. But they did not get it from the visit to Ford's plants. What they actually found when they went to the Ford plants was, oh, these things are huge. They're building in large batches. And they have giant warehouses where they just keep a lot of inventory. And they were like, we don't have the space in the land to do that in Japan. We can't run our operations that way. But what they did discover were these things called American supermarkets, grocery stores, and how they managed inventory. So my first job, when I was 15, so working at a grocery store, I stocked shelves. That was my job. And so I would put canned food, cereal on the shelves. And how would I know when to put something on a shelf? When it was missing. That's it. When it's empty, right? It's that simple. And if it's not empty, I don't put anything. And so that's what, instead of, there's two principles of inventory management. One is called a push system, which is I make it and send it to you as fast as I can. And the other is a pull system, which says I'm not going to send something to you until you are ready for it and have used what you had before.
So it's kind of random side note. So my dad sells stuff on Amazon sometimes. So he'll check out Walmart, like their clearance section, and if something sells good but it's on sale and he can sell it for more, he'll just buy the whole store out. So, and I've done well of that particular item, you were saying. And so,
Sure.
And so I've done this for him too. So I'll go find something that sells good, and I'll walk up to the manager and be like, "Hey, if I buy all these for you, can you give me $5 off a piece?" That kind of thing. And so usually they say yes, but sometimes they say no because they're like, "Oh, well, if we do that, then their main HQ people are going to send us a whole lot more." So how does that work with the inventory thing?
Yeah, so there's two things on that. There's foreseen and unforeseen variation in customer demand, right? And so I'll go back to relate to what you were saying to my older brother. Actually, my first job was at a grocery store. He spent like 25 years in the grocery industry. He delivered bread. And so if you think about a bread, Jimmy the Bread Man, that's what we called him. He would go in, he had multiple grocery stores that he was responsible for supplying bread to. And he had a bread shelf, right? And it had different amounts of different product on it. And he would go in and, just like I said, he would decide how much of which type of bread to put on the bread shelf based on what was missing. And if there wasn't room, he wasn't going to just keep pushing bread out. But then something had to dictate how much of which type to put on the bread shelf at any given time, right? So, starting to get a little warmer in Alabama, at least. People are going to start grilling out a little more, probably. Definitely as we get to Memorial Day and 4th of July, right? Do you think the mix of product on the bread shelf on the 4th of July looks different than just regular March Day? Yeah, he would put out extra tables. He would stock it with barbecue bread and all kinds of hamburger buns, extra stuff. So then,
And that's what really,
yep. So then if, yeah, he puts more out, and then if it's not all bought, we incentivize people. But that's foreseen demand, right? Because he knows the 4th of July is coming.
you get that forecast.
Yeah, it's probably, exactly. He knows it because it's the 4th of July is about the same day every year, right? It's the day before the 5th, but then there's also unforeseen demand. Anybody wake up to snow yesterday?
At work, yeah.
A little unexpected for me. I don't pay attention to the news, or I don't know if it was actually, I knew it was going to get colder. I didn't know it was going to snow. If you're native to the South, when they forecast snow, what do people tend to do?
Stock up.
Stock up, lose their minds,
Seal up,
go buy milk, buy bread, eggs, yeah. So bread, in my brother's case, it used to be a weather, a meteorologist on here locally, and it's been a long time. His name was Dan Satterfield, and my brother couldn't stand him because he would always get super excited about snow and get everybody fired up, and they would rush the grocery stores and wipe out his bread, and then he would have his customers calling him and saying, "We need more, we need more, we need more," and he'd have to jump through hoops and get them stuff, and by the time he got them stuff, nobody needed it anymore. And that was unforeseen demand. And so there's forecasting, which is trying to understand inventory levels, but then either due to unforeseen demand, things we didn't expect, or for forecasting, we start playing around with this. Oh, we'll let you buy more of these. We'll put them on clearance because we had a lot more than we didn't sell as many as we thought. So we'll incentivize you to try to buy them, or in some cases, yeah, out of date. And then, or in some cases, it's like, you know what? No, I'm not going to give you a deal because I know I can sell this in this other arena. So when it comes to inventory management, when I've worked with companies, I always say, what's the mix and the quantity in your bread shelf need to look like? And you try to track demand data from the past. If there's things that we know, having talked to customers looking out in the future, that might help us to ramp up or not. And then you add safety factor in based on comfort and the cost of getting burned. And then some people are more conservative or more aggressive than others.
Yeah, like you're forecasting with different locations as well. Like my locations might sell this product of dairy or whatever better than the other store. So it's like, why do I give them more of my product when I can just go down, a couple more blocks to this location?
Yeah, and look, I was in Tempe, the Phoenix area, at a conference over spring break. The mix of stuff in their grocery stores and mine are very different. It's like soy jerky. What the heck is that? I didn't even know that was a thing. Yeah. But I couldn't find beef jerky anywhere, so it's like, I did.
Was it good?
It wasn't bad. I didn't hate it. It wasn't as good as what I'm used to, but yeah, sometimes it can be regional. So like that, there's a whole area, right? And industrial engineering, a big chunk of it, production inventory control. The companies sell whole systems that help you understand customer demand and automatically calculate. And then they're so accurate that somebody goes and sells them another system because their old one's inconsistent. And so production planning, inventory control is all part of it. But there's really two methods. There's the push system, which says I'll make it and send it whether you need it or not. And then the pull system, just in time, which is I'm only going to send it when you need it. And Toyota was a pioneer of that. And like I said, it was the oil crisis in the 70s that really turned people's attention to them. So as people started studying, and today Toyota It's the largest automotive company in the world, usually in the top 10, 15 largest companies in the world, period. Was the largest manufacturer, probably second largest next to Apple now, if you consider Apple, everything that is Apple just manufacturing, which it isn't. But so very successful company. Why do we care about Toyota? Because since post World War II, since 1951, only 1 year, this is 2026, so over 75 years, only 1 year have they not recorded an annual profit. And that was 2009, I believe. There was a global recession. Then and they rebounded the next year. I don't know any other company over 70 something years that can say that. So people have studied them. There's business case studies. People have been trying to figure it out. But Taiichi Ohno in the book Toyota Production System said, we're not really doing anything secret over here on the island. All we are trying to do is reduce the time from the time a customer places an order to the time they get it and we get paid for it, by shortening that time down by removing non-value added steps or waste. And so the whole Toyota system, which became known as Lean, is based on three fundamental principles: standardized processes so that we can have built-in quality, Jidoka, which we learned from the loom; deliver product to customers just in time, which we learned from the grocery stores, so that we can achieve our goals of high quality, low cost, fast delivery to the customer. So they used a house model to represent what they were trying to do, because the goal was the roof. We want high quality products at a low cost, fast delivery to the customer. We want to be able to do all three of those. Those are the desired results. Just like having a roof over our head is the reason we have a house, but we can't just have the roof. We can't just build the roof and expect it to stand. We have to start with a foundation and strong walls, strong pillars. So the two pillars are just in time and Jidoka. That's what allows us to achieve the results. But those don't stand strong if we don't have standardized processes. And so that became known, that became the Lean system. And people began studying it through this, starting in the 80s and the 90s. And as Toyota began to get more attention, they started to entertain getting more market share in the US because they had fallen behind. Honda and Datsun, which would become Nissan, had more market share in the US than Toyota, and they were looking to get into it. But Toyota, interestingly enough, and like I said, they learned a lot from Edwards Deming, plan, do, check, act cycle. Everything is always an experiment. So I shared 3 articles with you to read on Toyota. And one of them is called The DNA of the Toyota Production System. And they talk about how they tried to develop a community of problem solvers and treat everything as an experiment. And the company tends to do that as well, including at the strategic level. So in other words, in the 1980s, they were looking at having operations in the US, but they had a big question. Does this stuff work outside of Japan? With this whole different management philosophy that we have in Japan, work in the West? And so they didn't know. And so treated as an experiment before they jumped in on their own. They approached General Motors and did a joint venture in the early 80s called NUMMI, and which stood for New United Motor Manufacturing Incorporated. So they took, GM was about to close their worst performing plant in Fremont, California. It was very unionized. It was the worst in every metric: quality, workforce grievances. They would sabotage vehicles by putting Coke bottles inside the door panels, and it was just a negative environment, and they were closing it down. And Toyota approached them about doing the joint venture, and they decided to keep this facility, invite all the workers that they had laid off back. About 80% came back. And this is I shared another article talking about the NUMMI project. And the difference is same facility, same equipment, same workers, except now we're going to use the Toyota management style versus the GM management style. And within a year, they had they were the highest performing plant and for GM, and the quality was equal to or sometimes exceeding Toyota's plants in Japan. So they proved, plan, do, check, yes, we're better. Then Toyota built their first facility in Kentucky in the late 80s in Georgetown, Kentucky, which for a long time was their North American headquarters. It's in Plano, Texas now. So the NUMMI project proved successful. And lessons from the NUMMI project, it was interesting. In the article that I shared with you, How to Change a Culture is the name of it. It's written by a guy named John Shook, who was one of the first Americans to work in Japan in a leadership position for Toyota. And he talked about the differences in how the Toyota system, which says we give everyone on the line the responsibility, not just the authority, but the responsibility to stop the line when there's a problem. And that blew the General Motors people's minds. It's like, what? You're going to let them do what? We can't stop the line. We got to make stuff. And just two different mindsets required a different way of thinking. And one of the lessons that came out of that article that's part of the reading for this section, How to Change a Culture, was the old way of thinking was if we change what we say, we could expect a change in behavior. And I work at companies. Again, most of my career was trying to implement lean at companies. And a lot of times people would do it this way. They would say, hey, we're going to do this stuff. I'm going to put a banner up in the break room that says, we believe in this, 5S, lean, we're going to do it. And everybody just start acting. But a change in thinking, a change in professed mindset doesn't lead to a change in behaviors, but a change in behavior will ultimately become your new culture and lead to a change. That was the lesson from NUMMI. Don't say you're going to do something different and expect a change in behavior. Change your behavior. Lead by example and expect, and then the change in thinking will come from the proven results. So all of that, Toyota established based on lessons from NUMMI, their first operations in North America in the late 80s. They grew during the 90s and almost to a detriment. I had a really good friend, one of my Toyota mentors named John Watson, and he was Canadian, Big John, and he worked at Toyota in Canada in the mid-90s. Then he moved to Alabama to work for Mercedes when they at their Tuscaloosa facility. And then he went back to Toyota in the late 90s, and he said it was totally different than when he was there in the early 90s. And he said they had grown so much that they had started to slip from the standard that they expected because they grew too fast. And realizing this in 2000s, the Toyota Motor Corporation chairman at the time, Fujio Cho, commissioned a group to come up with something called the Toyota Way 2001, which was a standardization and documentation of the company's culture. So where the original Toyota production system was shown as a house, and it was all about the technical production system. Here's how we have standardized processes. Here's how we build quality. Here's how we manage inventory to get results. And what they realized is the technical system worked, and they proved that at NUMMI, but it only works with the right culture. And that part wasn't documented and understood outside of Japan. And really, it's not even just a Japanese thing, it's a Toyota thing. And the piece that was missing, the continuous improvement piece, was the technical side, but then the culture also was about respect for people. And so the Toyota production system in 2001 became the Toyota Way, with a stronger emphasis on organizational culture, with the foundation being their 5 values of challenge, kaizen, Genshiken Butsu, which means go see the real place with your own eyes, respect, and team. So from a continuous improvement side, that was how do we improve our processes? How do we do the technology side, the technical side? So from the way we're viewing the 3 industrial revolutions, that's the second P, processes and technology. Well, Kaizen, which is Japanese for good change or continuous improvement. So Zen means good. We all kind of heard that. Oh, I want my Zen garden. I want my balance. Everything's good. Zen means good. Kai means change. So Kaizen is change for the better. So in a lot of US companies that are doing lean, Kaizen is a actual problem solving effort or an event. In Japanese, it's more of a deeper meaning of always continuously trying to get better as a person in every aspect of life. Problem solving, challenge and problem solving means changing our mental model of how we view problems, not hiding problems, but surfacing them and embracing them. So like you were saying, we had quality, did you call them quality fun days?
Quality walls.
Yeah. So where it's like, hey, good catch. Share this problem that we found. We at Mazda Toyota, a lot of times they have signs posted. It'll say like "good catch," and they'll have the person's picture and the quality problem that they found, and they celebrate surfacing problems because the problems are there, whether we acknowledge it or not. So having a culture that says we embrace problems and we problem solve, and we can only effectively problem solve if we develop everyone in the organization to do it, which is what the DNA of the Toyota Production System article talks about. Not just expect our managers and our engineers to fix our problems, but developing everyone as a problem solver with the right mindset. And that kind of leads into the second aspect of the Toyota Way, which is respect for people. And they had to be very explicit by what they meant by this, because in the West, sometimes it was misunderstood what Toyota meant by respect. I grew up in the South. I thought respect is holding doors open, saying yes, sir, yes, ma'am, no, sir, no, ma'am. And that is polite. I'm not saying it's not respectful, but that's not what they're talking about. And they certainly aren't talking about respect for people, make it easy. Respect for people. This is a good quote. A person's life is an accumulation of time. Just 1 hour is equivalent to a person's life. They provide us their precious hours of life to the company. So if we don't use it effectively, we're wasting their life. In other words, we expect people to think. Theory X versus theory Y, as Douglas McGregor called it. We expect people to think. One of the phrases I think we looked at very early in the semester, like class 2 or so, when I was looking at the different management styles. One of the quotes I always liked was at Toyota, we build people, not cars. We don't build cars, we build people. And so part of respect is Ginshi Genbutsu, which is go and see. Go see with your own eyes, and when you problem solve, go and see, show respect, and ask why the problem happened, not who caused the problem. I spend more time by the time I get undergrads now, I used to teach 300 level, junior level, sophomore, junior level classes, and I like that. I miss it. Now I get them as seniors in senior design, so it's right before this is final inspection. Right? Like this is I'm catching them right before they get to the customer, and hope we don't send defects to the customer with our graduates. But one of the things I spend a lot of time with them on is Don't think you have all the answers and don't think you have to have all the answers. Go and see. The first part of their project should just be spending time at the process, talking to the people who do the job, understanding, mapping it out, collecting data, not just changing things. Go and see with your own eyes. And when you do go and see, show respect. Wherever the work is, if I'm improving a manufacturing process, show respect to the person that does the job. It made me very proud, and maybe they were just telling me what they thought I wanted them to hear. But when my teams were presenting their midterm reports today, a couple of them mentioned, well, we went out and we took this idea, we talked to the people doing the job, we got this feedback, and we adjusted our idea, and we were doing that. Great, that is a skill set that we don't teach in engineering. We do teach it in engineering management because it's that important. Or if I'm making improvements in an office process, I want to go involve the people who do the job. I want to engage them in the problem solving. And then when a problem happens, not blame, but ask why to get to the root cause. That's the spirit of Genshin Kambutsu, and that shows respect. And teamwork, involving people, everyone having roles, as well, coaching, developing people. So continuous improvement, adding respect for people, rounded out the Toyota system, and all of that grew during this third industrial revolution. A major contributor to not only just the processes and technologies and quality, but management principles and philosophies as well. Another big school of thought in the quality world that emerged during the third industrial revolution is something called Six Sigma. Six Sigma is another continuous improvement methodology developed at Motorola and then made popular at General Electric under Jack Welch, who advocated it as very data-driven, statistical-driven, using a lot of Deming's techniques, statistical process control. So Six Sigma, by definition, means plus or minus 6 standard deviations from the mean of a normal distribution, a Gaussian distribution. So if a population is normally distributed, you have the mean, which is the average of whatever metric you're interested in. If I wanted to measure height of everybody, and we may have an average height of 5'9". But then plus or one, maybe the standard deviation of that is 3 inches. So plus or minus 1 standard deviation would be between 5'6" and 6 foot. So you might say, and then usually in the normal distribution, 65% of the population falls within plus or minus 1 standard deviation. 95% fall within plus or minus 2 standard deviations. 5'3" to 6'3". I'm making numbers up. Don't hold me to this. And then plus or minus 3 standard deviations. 5 foot to 6'6", 99.74% of the population. All the way to plus or minus 6 standard deviations captures 99.39 and 2/6%. Which means if I have 6 sigma level quality, I'm only making a defect every 3.4 million opportunities. So they use the term 6 sigma to basically say we're striving to eliminate variation and defects to have perfect quality. But it's really an application of a set of statistical tools following a structured problem-solving process. They call it DMAIC. Define the problem is the D. Measure the current process is M. Analyze the data that you measured. That's all the plan phase of plan, do, check, act. So all the problem-solving methodologies follow the same pattern. Improve, which is the do of the plan, do, check, act phase, and control, which is kind of the check and act, which is how do we sustain this and monitor it and adjust as needed. So Six Sigma was known for a couple of things. outside of the set of statistical tools, one is their standardized problem-solving methodology, DMAIC, and the other is their marketing, which is calling everybody belts based on the martial arts system, which got people into getting certifications. So there's a general accepted body of knowledge of yellow belt, which is having had training, green belt, which is having a basic understanding of statistical tools, and you can do the heavy lifting on projects. Black belts, now we're getting really fancy, which focus on project management and making sure green belts are working on the right things. And then master black belts, now we're really, really getting fancy, to train and mentor black belts. So they had the standardized problem-solving methodology. Then they also added some structure to the practitioners as well. Now, then consultants got really, really cute in the 2000s and started saying things like Lean Six Sigma. And as a lean guy, there's no such thing. Usually that's following the Six Sigma process with a few lean tools, 3M. Lean is the Toyota philosophy of how to run a company. And I don't really I have certifications and all of that. And I don't put a lot of merit in it because it's kind of like I trained jujitsu for 20-something years. Like either you know what you're doing or you don't. You don't care what belt you are. And it's kind of the same thing with this stuff. Either you know the tools, you can do process improvement, not. And certification is just its own separate thing. But that's kind of what Six Sigma was known for. So those were two major thrusts in the quality world, Lean Six Sigma. And then another thing that became a big thing and a role of the engineer and the field of quality engineering during this third industrial revolution was the establishment of quality management systems. So ISO 9000 is the most common one. ISO, International Organization of Standards, IOS, which is ISO. ISOs is Greek for the same. But it's the organization developed in Europe that kind of said, if you have these things, this is a quality management system, and then you can get ISO certified, which a lot of times organizations will give you preferred, they'll usually be more likely to be a customer of yours if you can show that you have ISO certified quality, which basically means you have a documented system. A lot of people think ISO tells you how to do things, and it really doesn't. All it's saying is you need to have defined processes of how you do things. And when we come and audit you, you need to be following those processes. So that became a job of a lot of people in quality engineering. So there's two kind of directions that someone can go. So in ISO, different industries have their own versions. Automotive has TS 16949, which has very specific quality standards just for that industry. AS 9100 for aerospace, medical devices, everyone has. But there's basically these categories that ISO says you need to have procedures and processes for how you show that you have a customer focus. What are your leadership processes? How do you engage employees? What is your continual improvement? And have them documented. So in the quality world, in quality engineering, which often falls on as a subset of industrial engineering, there's the continuous improvement world, which I spend a lot of my time in, which is going hands-on on the floor, improving quality at the process. And then there's the compliance side of quality as well, which is managing the quality system. And so I think that's one of the things that I wanted to emphasize in this class, is that became a role during the third industrial revolution that engineering grew into. So in the first industrial revolution, it was all about inventing, building stuff and technologies. In the second industrial revolution, we will always design, invent, build stuff, but we took on the role as engineers of being productive with stuff, on improving stuff. And then in the third industrial revolution, oh yeah, we can't just be productive, we have to have quality as well. And that became a role. So not that we're getting rid of roles in engineering, as we are going along, we're adding to that role. And we saw quality become part of that. And so I wanted today to touch on some of the major contributions of the third industrial revolution, specifically in that area. So Joseph Juran, Edward Deming, the early part of the third industrial revolution, the Toyota system and their emergence, in the middle of it, and Six Sigma, and then the fact that quality systems become more and more common with the ISO 9000 and the different variations.
Not to look ahead, but
Sure.
is the fourth module about like Agile Manifesto and that's like a response to some of this stuff?
I don't really cover Agile a lot. I don't know in EM6 if Dr. Williams covers it in project management much at all. It's kind of a good approach. There's a lot of overlaps with Lean in terms of what Agile does in software development, in terms of the quick iterations and adjustments and things like that. In the fourth industrial revolution, at module 4, what we'll get into is really what are we doing now with this new wave of technologies that's hit? Because it took us 3 industrial revolutions to go from technology to being productive with technology to quality to now we've got a new wave of technologies again. The first industrial revolution and the second one were about 100 years apart. Second and the third were about 100 years apart. Third and the fourth about 50 years apart. Things are happening faster. We building productivity and quality in with a new wave of technologies or not. Like we're kind of in the middle of it. Like it's easy to reflect and see the first 3 industrial revolutions because like it's easy to define them when they've happened. We're in the midst of the fourth and people get cute and say, oh, we're in the fifth or whatever. I don't know, fourth and beyond. But I think it's more of a reflection back and go, what can we learn based on this new wave of technologies that we have now? AI is the big one, machine learning, blockchain technologies, and additive manufacturing, robotics, automation, all the data analytics and data science. We'll look at that in the fourth industrial revolution. And we'll also look at some of the modern management philosophies that have emerged. It'll be fun. And then we'll wrap it up, the last class, with the people aspects of what are we learning. So we introduced in class 2.3 like Maslow and workforce motivation, or Maslow is just human motivation in general. Like, oh, we're studying this stuff in psychology. And McGregor with Theory X and Theory Y, we'll talk about next week some process approaches to workforce motivation and goal theory. And then what are we doing now? We'll look at that module 4 with some neuroscience and how that can help us shape what we're learning and manage with really cool stuff. It's kind of what we got. I hope y'all have a good rest of your week. Glad to be back in the classroom. I apologize. Never missed that many classes in a row. Hope to not miss that many again.